Hello and welcome back. And in the previous video, you know that we have discussed about the Bayes theorem. So Bayes theorem is basically all about the conditional probability. So we have seen that formula and the derivation of that formula in the previous video. Now we can have the extension as well for the Bayes theorem, right? We will understand that when and how this extension of the Bayes theorem can be used. You can see wherever I am highlighting, this one is the extension of the Bayes theorem. So P conditional probability A when B1, B2 up to B and these are there, then what should be the formula? So this is the extension, this is the expansion of the Bayes theorem. So you can see that this is the formula that which is applied, right? So what is the interpretation of the Bayes theorem? That also we have discussed in the previous video, but let me remind you, let me revise it for you. So Bayes theorem helps us update our belief about an event A based on new information B. It combines prior knowledge, which is the probability of A, with the likelihood of the new information, which is the probability of B when A has occurred, to produce an updated probability of A when B has occurred. Right. So this is the interpretation of the Bayes theorem. So we will see this with the help of an example that why this interpretation is useful and why this is the real interpretation of the Bayes theorem, right? So you can read it again, and if you have seen the previous video, then most of the things should be clear to you. But with the help of the examples that we are going to discuss today, with that it will be more clear to you. Okay, so here is an example of using Bayes theorem to find out whether a mail that you get could be a spam mail or not. Okay, so usually in the spam mails you can see few words like free, right, prizes, something like that you are able to see in the spam mails. But not every mail which contains the free or which contains the prizes, all these things which are very common, which are identified as a spam mail, this cannot be true for all the cases, right? So it's not like whenever you will see the free word, then you will say that yes, this is a spam mail, right? Not every time. So there, at that case, at that condition, in that condition, this particular Bayes theorem will be useful for you to identify whether a mail is a spam mail or not when the specific words like the price or the free, these words are available in the mail. Then what is the classification of the mail, whether it's normal mail or a spam mail? So our goal is to predict the probability that an email is a spam given that it contains the word free. So we know that we have a word free in our mail and we want to know whether this is a spam mail or not. We want to basically know the probability. So the first step is that we have to define the prior probabilities, right? We have to define the prior probabilities. Suppose probability of mail to be spam mail when there is a free word. Okay, there is a word free, then what is the probability of an email being spam? It is 0.1. 10% of the emails are spam. Okay, when there is a free word. Okay, probability of, and then there is a free word probability of an email containing the word free. Sorry, first one was just like without being free word, right? A normal mail is a spam mail or not. A normal mail is a spam mail or not. The probability of having that is 10%, and now probability of an email containing the word free is 0.05. 5% of the mails contains the word free when they are spam mail, right? So any mail that you get, the probability of that mail being a spam mail is 10%. But among those mails, if the mail contains word free, then if it is a spam or not, that probability is 0.05, which means 5% of the mails which are the spam mails, they contain the word free. So I hope you are understanding the prior probabilities. So these prior probabilities, from where you get it? These prior probabilities, you get it from the training material, from the training data. Okay. Now we have the conditional probability. Define the conditional probability. It will be found from the training data. This will also be found from the training data, which is the conditional probability. One conditional probability is that you have a spam mail and the probability that it is containing a free word, right? This is the probability. that you have a spam mail, you have categorized a mail as a spam mail, and that mail contains a word free, right? So what is the probability of that? I mean, how much percentage of the data, your training data contains the word free if it is a spam mail, right? Then in that case, we see that from our data, it's like 80%. So 80% of the mails contain the word free. From training data, it can be found, or it will be found. So from your training data, it could be having something else as well. I mean, it is based on your training data that you're providing, right? So after that, we have another one. We don't have a spam mail, but it contains the free word. Or you can say it's like PF and negation of S. You can write like P, you know, uh, you can say like probability of an email containing free word given that it is not in a spam. I mean, if you have a word free in your email, but still it's not a spam, what is the probability of that? Only 1% of non-spam email contains the word free. This could be again be analyzed from your training data. We are just assuming, right? Right, we have right, like we have this kind of data where we have such kind of mails which contains the word free, but still they are not the spam mails, and the number of such records are only 1% of the total sample data. Okay. Now you apply the Bayes theorem. We have to find whether a mail is spam or not when the word free is available. Okay, in a mail. So you can apply the Bayes theorem. So this is the Bayes theorem. You have to find out whether the mail is a spam mail when the word f free is there, right? So you have this formula: probability of a mail being spam multiplied by probability of a mail which is a spam mail and having the word free divided by probability of f. I mean, probability of finding the word free, right? So this is from the sample data, you find the probability of all these things, right? Like all these values you can find on the right hand side. You have to find out the value of left hand side. So if you plug in the values, then you find that 0.32%, 0.32, which means 32% of the emails, if they contain the word free, they are or they could be the spam mails, right? So you have seen that given that an email contains the word free, the probability of that it is spam, it's 32%. Now we can interpret these results. So what does this result says? Bayes theorem helps us update our belief about an email being spam based on the presence of the word free. Initially, we thought like 10% of the emails were spam, right? Only 10% of the emails were spam that we have seen right here. Probability of an email being spam. This was the initial understanding that there was only 10% of the mails which are spam. But after the analysis and after applying the Bayes theorem, we have more substantive analysis, and we have found that after seeing the word free, if you have any mail which has the word free, then we can update our belief that around 32% of the mails having the word free could be spam mail, right? So this is because spam mails are more likely to contain the word free, which is 80%. The chances are there with 80%, right? So this is the basic example that I wanted to show you before we can understand that how the Bayes theorem using the Neve-Bayes classifier has been used for the sentiment analysis, right? So I hope you might have understood this basic example, and you might have now understood the real use of the Bayes theorem. In the college days, you might have just played around few of the questions and few of those questions which are really important for your examination, right? So those days are gone. Now you have to jump into the real world, and now you can understand that how these concepts are really used, which are from the mathematics. Okay, so I hope you might have understood it clearly. If you have not, then please go through this video again. Please go through my previous video again, because without these videos or without these lectures, without the understanding of these concepts, you will not be able to understand what all has been done behind the scene. So I hope you might have enjoyed it, and in the next video we will meet soon. Till then, have a nice day and bye-bye. Thank you.